When supermassive black holes are growing and they have the accretion disk, you have material that's swirling in, and all that light can basically drive a wind. And the way that works is the actual individual photons, the individual light particles have momentum. They carry a punch. And so when they encounter gas, they can blow these really energetic winds. And the way they might impact their host galaxy is that depending on how much mass is in the wind, so the mass could easily be a few times the mass of our sun, which is comparable actually to the amount of gas that's falling into the black hole per year. So a few times the mass of the sun per year could be coming out as winds, and a few times the mass of the sun could be falling into the black hole and causing the mass to grow. So if you have that much gas that's being blown out from the central part of the black hole, of the black hole system in the center of a galaxy, and it's going out at tens of thousands of kilometers per second, that gas has a lot of energy. And what it can do is it can impact the other gas in the galaxy, and it can do, we're not quite sure what it could do, but what it could do, there's sort of two things that it could do. One is that you have gas that's coming out at very high velocity from the center of the galaxy near the black hole, and it can basically plow into other gas in the galaxy. If it has enough energy, it can actually plow it out of the entire galaxy. And what happens is if it blows all the gas out of the galaxy, it can completely shut off star formation, because that gas is the fuel of star formation. What it could also do, if it's not going as fast, is it could plow into the gas in the galaxy and it can compress it. And if it can compress it, it might actually trigger star formation and cause star formation to occur. So either of those two are plausible explanations, but what we really need to do is we need to learn more about the properties of the actual winds. What are the velocities? What are the geometries? How much mass is in them? And once we have a better handle of that, then we'll have a better idea of how it actually is impacting the galaxies that it lives in. But those are sort of the most extreme scenarios. It could enhance star formation by causing the gas clouds to compress, or it could just blow out all the gas and shut off star formation. And that's why the event of being a quasar, which is something that all massive galaxies go through, it's kind of like being a teenager. It's just like this phase of life. It's kind of dramatic, it's potentially unpleasant, and you're definitely different afterwards. But it's not clear what the change actually will be. And so that's something that I think is really fascinating, and one reason why, if you really want to understand how galaxies evolve, you have to understand how their black holes grow, because this quasar phase could be really fundamentally important to shaping them over time.